Good morning. I am Professor Snehal Revatkar from Tulsiramji Gaikwad Patil College of Engineering and Technology, Department of Computer Science and Engineering, presenting design pattern. These are the contents: introduction, type of structural design patterns, decorator design pattern, when to use, structure and benefits. The second type of design pattern is structural design pattern. The introduction, structural design pattern. It shows how to assemble classes and objects into larger structure, focusing on simplicity and the relationship between entities. They help create more complex, flexible, and efficient systems by managing how components are composed and connected. The main goal is to build robust, maintainable software by reducing dependencies and allowing components to work together, even with incompatible interfaces. By using structural patterns, you can manage the complex classes hierarchies, reuse existing codes, and create scalable architectures. In structural design patterns, the decorative design patterns are included. This is a type of structural design patterns. Let's dynamically add behavior to individual objects without changing other objects of the same class. It uses class decorator classes to wrap concrete components, making functionality more flexible. And imagine that you are working on an app for a pizza restaurant. Initially, you only had one kind of toppings, pepperoni. The problem is, if you want to offer other types of topping as well, use may users may want multiple toppings at once. Even having three toppings increases the number of combinations to 8. The solution is we can create the decorator or wrapper class that can be customized to meet specific needs. Object of this class can use the behavior of various classes, having references to multiple objects and delegating them all kinds of works. This is the basic structure of decorator design pattern. The first class is I component. It is an interface component. The role of I component class, it declares the common operations, execute functions that both concrete objects and decorators must implement. The second is concrete component. The role of concrete component class, the actual object you want to add extra behavior to. It implements I component and provides the real implementation of execution functions. The base decorator class, the role of base decorator class is to wrapper that abstract wrapper that also implements I component. It stores the references to an I component object labeled wrappy I component and its own execution function calls the wrap components executed by default. Last class, fourth one, is a concrete decorator, a specific decorator that adds a new behavior and it also implements the inherits from base decorator that overrides execute function to add extra features before or after calling. The flows of calls, the client works only with I component types. The concrete component is created. One or more concrete decorators wrap that component. And fourth execution, when execute function is called on the outermost decorator, it runs its extra logic, then delegates the call down the chain until the base concrete component executes. Benefits of decorator design pattern. First is open close principle. You don't modify the original class to add new behavior. Instead, you extend the object's capabilities by wrapping it in one or more decorators. This class open for extensions but close for modifications. It means open close principle. The second is avoids subclassing explosion. To represent every combinations of feature, you need to add the one base class plus multiple small decorators. You mix and match decorators at runtime to form any combinations. Third is dynamic composition. You can add or remove responsibility at runtime rather than at compile time. Decorators are objects themselves, wrapping the components. And last is flexibility. Because decorators are independent, you gain the several forms of flexibility. Means order of combination matters, selective use and reuse. Means the same decorator can wrap many different components. Thank you.